Second half of section 10.2 is on the binomial theorem. And this is a little bit complex, but it's oh so fun. So hang with me here for just a minute. So this triangle here represents what's called Pascal's triangle. It was discovered by Blaise Pascal, and so you've got to find something, and then you can name it after yourself. So Pascal's triangle, if you'll see the sum of the two numbers catty corner from the number is the new number. So 1 plus 1 is 2, and 1 and 2 is 3, and 3 and 3 are 6, and 1 and 3 are 4. So you can see how it comes down, and that's how we have the new numbers in this triangle. Now, the reason I'm bringing it up now is because this is so cool. These numbers correspond with the combinations at each of these levels. So the number 1 matches up with the combinations of 0 taken 0 at a time. There's one of them. The combinations of 1 taken 0 at a time is 1, and the combinations of 1 taken 1 at a time is 1. The combinations of 2 taken 0 at a time is 1. Combinations of 2 taken 1 at a time is 2. Combinations of 2 taken 2 at a time is 1. Do you see where this is going? All right. Same thing here. Combinations of 3, 0 at a time. Combinations 3, 1 at a time. Combinations 3, 2 at a time. Combinations 3, 3 at a time, and so forth. So what we can do is we can either use that formula that I showed you in the last video, or you can use Pascal's triangle. Now, honestly, this becomes a little bit cumbersome the larger you get, but it's kind of cool, don't you think? All right, so I want you to know, let's see. So if we have a collection of 7 caps, and I want to trade 3 of those baseball caps, what is the number of combinations that I have as options for trading these 3 caps? That's what I want to know. But I specifically want you to use Pascal's triangle. So in order to use that, I want the combinations of 7, which means I need to get down to the 7th row. Yes? So this is the 6th row, and this is the this is the 7th row. So I need to get down to that 7th row. Finding these new rows, it's really a simple addition problem. So 1 comes down here, 5 and 1 is 6, 15, 20, 15, 6, and then 1 goes in the corner. So I need to find the 7th row. Do you see how I'm finding the new rows? 1, 6, 7. Uh-oh, I can't add in my head that quick. 10, 21, 20, 35, 35, 10 and 11 is 21, 6, 7, and 1 over in the corner. All right, so if I want to know, I want to trade 3, so I want a collection of 7 caps taken 3 at a time. So now we look to see, this is the combination of 7 taken 0 at a time, combination of 7, 1, combination of 7, 2, aha, here it is, combination of 7 taken 3 at a time is 35. So the answer to that is simply 35. Easy. So we could have used that formula and taken 7 factorial over 7 minus 3 factorial times 3 factorial, and we would have gotten the same 35. But check this out. Okay, so 7 factorial over 7 minus 3 factorial times 3 factorial. This is 4 factorial, so 7 times 6 times 5 times 4 factorial, which will eliminate, and 3 times 2 rules out the 6. We've got 7 times 5, which is 35. Ha! Isn't that cool? Okay, so something else in with that. Okay, there's more. There's more. There's always more. All right, the binomial theorem is going to use Pascal's triangle here that we've just established. So the binomial theorem, and it looks very confusing, all right, with all the A's and B's and N's and here. So just hang with me. Let's look through it, and then when we do it with actual numbers, it'll, oh, I get it. That makes sense. So if you've got, the binomial theorem says that if you've got a binomial that you're taking to the n power, the coefficient on each of the new terms is going to be a combination. all right? And it's a combination of that number taken 0 at a time, then 1 at a time, then 2 at a time, then 3 at a time, and so forth, all right? Which means that those coefficients are going to match up with Pascal's triangle, all right? So the coefficients are going to come off of the triangle. And then the variable terms are going to come, so you're going to take the first term to the n power, and then the second term to the 0 power. And then in each term after that, the first term is going to diminish by 1, and the second term is going to increase by 1. Okay? Let's do one so that you can see it happening, and then it'll make more sense. So if I want to take x plus y raised to the 6th power, the first thing I'm going to do is I'm going to get my coefficients, all right? And I'm going to go get my coefficients from the 6, from n equals 6 row. So this is going to be my row where my coefficients are 1, 6, 15, 20, 15, 6, and 1. All right? So the first coefficient is just 1, so we're going to leave it off. And now the first term is going to be the first term of my binomial to this power. And then the second term to the 0 power, and remember anything to the 0 power is 1. All right? Now my second term is going to have 6 as the coefficient. And now my first term is going to be the x, and it's going to diminish by 1. It's going to be 5th. And the y is going to be 1 greater, so 1 bigger than 0 is 1. Then you're going to add 15 as my coefficient, and the x is going to go down by 1, so x to the 4th. Y is going to go up 1, so that's 2. New coefficient, 20. The x is going to go down by 1, so x to the 3rd. Y is going to go up 1, so y 3rd. And we don't have enough space, so we're going to come down here. Plus, after 20 comes 15. And we have x, we were at 3, so we're going to go down to squared. Y was at 3, so it's going to go up to 4. And then our next coefficient, oh, am I in the right spot? Yes, 15, 20, 15, 6 plus 6. And now x is going to go down 1, so x. And y is going to go up 1, y to the 5th. And then our last coefficient is just 1, so you don't have to have the coefficient there. And the x is down to 0, and the y is to the 6th power. Ha ha, isn't that cool? That's pretty fun. All right. Now, what you're going to do, you've got to be careful. This was easy because the x and the y were just by themselves. Make sure that if the x is squared, or if you have 2 times a y, make sure that you're taking, when you take this part to the 5th power, that whole thing that's in there is taken to that power, okay? So if you had, well, let's just change it real quick. Let's just say you had x squared here. All right, if you had x squared here, so then your first term, we're just going to do the first term. If this was x squared, your first term would be x squared to the 6th power, which would be x to the 12th. Okay, that makes sense? Okay. All right, if that still doesn't make sense, then come and see me in class. We're going to move on to this one, and that it might make more sense because this one is a little bit more, it's got some other things in it, so that'll help us to see other options. Okay, so now what we're going to do is, well, that was added. That was easy. If you've got a difference of 2 terms, then your signs are going to go back and forth, positive, negative, positive, negative, positive, negative, okay? So if you're subtracting, so make yourself a little note there. If you're subtracting, if your binomials are subtracting, your signs are going to be opposite. Okay, so what we've got here is, okay, and this is going to be a little bit more crazy because you've got numbers instead of just an x and a y. So let's watch what happens. So 4th power, so we're using this 1, 4, 6, 4, 1. You can even put 1, 4, 6, 4, 1 if you want, so that we're down here together. So now you're going to do the 1, and you're going to do the first term to the 4th power. So 3x, the whole thing to the 4th power. All right? And then you're going to, this was positive, so the next one is negative. And so now minus, and then you've got the first term. So the 3x is going to go down. Oh, wait, first we've got to get our coefficient of 4. All right, and now the coefficient of 4 is going to be multiplied by, the first term is 3x, and that is going to go down by 1, so that's to the third power, times 2 to the 1 power, because that's going up from 0. Now that was minus, so this is plus, and then you've got 6, and then you've got 3x, to the, we're at the third, so we're going to go down squared, times 2 to the 2 power, because it was at the 1, it's going to go up. Now this was plus, so now we have minus. And then, let's see, we had 6, now we have 4. You see where I'm getting the coefficient times the term. To 1 less power is just the 1 power. And the 2 is going to go up 1, so it's to the third power. And then we were at minus, so now we're going to go plus. And now our coefficient is 1. And now we have 3x to the 0 power is just 1, so we leave that off. And we have 2 to the 4th power. Now it's just a matter of simplifying. So make sure when you're simplifying that you do all of your, okay, so we've got 3. The whole thing is to the 4th power. So 3 to the 4th is 81. So you've got 81x to the 4th is your first term. And now 3 squared is 9, and 9 times 4 is 36. Oh, and then the 36 times 2. Woo! What is 36 times 2? 36 times 2, 3 and 3 are 6, 72. Is that right? That's not what I have on my notes, so I'm really confused now. Minus 72. Did I do something wrong? Oh, that's what I did, because this is to the third. And you're saying, oh, good job, good catch, good catch. 3 to the third is not 3 times 3. It's 3 times 3 times 3, so that's 27. So then I have to follow my notes because I can't do this in my head. So you'll take 27 times 4 times 2, and it should be 216. 216x cubed, then plus, and then this is 3 squared, this is 9, and 2 squared is 4, so 9 times 4 is 36, and 36 times 6 should be 216 if I did my math right in my notes. So 216x squared, and then we're going to take 4 times 3 times 8, 2 to the third is 8, 4 times 3 is 12, times 8 is 96, so minus 96x plus 2 to the 4th is 16. Whoo-wee! Okay, so that shows you a little bit more of what I was talking about up here. So the only difference. So one difference is you got to make sure you have each part is taken to that power. Each part of that term is taken to the power. And then you've got to remember if you're subtracting, then every other term, this one's positive, negative, positive, negative, positive. Okay? All right. Last thing, here we go. Oh, this is fun. This is fun. I love these. It's a puzzle. Okay. So what we want to do now is this type of problem. I want you to find the coefficient of x cubed y to the 4th in this term. So what we're going to need to do is this. We want the 7th row, right? And we have the 7th row, but where is it x to the 3rd, y to the 4th? Well, so which one of these is going to be x to the 3rd, y to the 4th? So you can do it on your paper, or you can go over to your triangle and you can say, okay, well, if you've got just the x, the first term is going to be, this is going to be x to the 7th, right? This one is going to be x to the 6th and y. This one is going to be x to the 5th, y squared. Do you see where I'm coming up with the numbers? The x's are going down, the y's are going up. This is going to be x to the 4th, y cubed, x to the 3rd, y to the 4th, x squared, y to the 5th, x, y to the 6th, and y to the 7th. So we're looking for x cubed y to the 4th, x cubed y to the 4th. So the coefficient is 35. Now be careful, because it's not just 35. Because remember, we've got to take this 2x, it's not just the x. So in this x cubed y to the fourth, that was 2x cubed, right? So the 2 is also cubed, so that 2 is cubed, which is 8. So you've got 35 times 8, which means that 35 times 8 is 280. So this is the coefficient. The coefficient in front of x cubed y to the fourth is going to be, so at that point in the problem, there's going to be a 280 in front of this x cubed y to the fourth. Okay? Because of this cubed on the x, and the x term is 2x, not just x. All right? There is a lot. I told you it would be confusing. I think if you stop and take it one step at a time, it's really quite fun. Okay? So the binomial theorem can take those, you take the coefficients from the Pascal's triangle. If you don't want to have your triangle there, you can figure the that spot where the combinations are. You can use the formula for the combinations if you would prefer to do that. Okay? All right, good luck. See you soon.